did not have a daily concept check because I wanted to finish the material for the test. But this time, I looked back at both last two sessions. Okay. So let's go through these. What I said, it's confusing. There are all these 6, and later on we're going to add one more. Okay? So these are confusing because they use the same words and they mean different things. So the average rate of change requires 2 distinct points. If you're not given 2 distinct points, you cannot determine the average rate of change, of course, of a function. The rate of change of f of x is f prime. So if we're asked, we are given a function and we're asked find the rate of change of this, then you know that you have to find f prime or dy by dx. They are the same. Value of the rate of change at x equals, I didn't know what to put, so I put a heart for you. So the value of the function of the rate of change at x equals whatever you want is f prime of that. The instantaneous rate of change of f of x is the same with this. F prime of x equals dx. The average profit, cost, revenue, etc. The average profit is p of x over x. The average cost is this. The average revenue is this. The rate of change of these is p of x over x prime. It's c of x over x prime. R of x over x prime. Now other topics, so the confusing part ends here. Later on, we're going to add one more confusing in chapter 4. It's in the same boat with these. It uses the same wording, either average, either rate, or value, or something. So we're going to add one more. Next, something that is not confusing, and we have to understand and remember these. Any rate of change has what? Thank you very much. The product rule, the quotient rule, the chain rule, 1 for the power, same thing. It's basically the same, but I want you to see the difference between the two. Velocity, acceleration. The velocity is the first derivative of the distance function. The acceleration is the second derivative of the distance function, or the first derivative of the velocity function. Okay, I think I wanted to add one more thing here, and then I'll come back to page 3. So again, a function of a function prime is the outer function prime times the inner function prime. Okay. So now coming back, I have a list of topics for test 1. And you'll tell me what you would like to start with. Graphing a piecewise defined function. Formula for the compound interest. Domain of functions. Equilibrium point. Limits, and also reading limits from graphs. Continuity. Differentiation or differentiability. Definition of continuity at a point. This is extremely important. Very easy and very important. Use a definition of the derivative to find f prime. Differentiation rules, we just reviewed them. Yes, and I want to add one more thing here, very important. 1 over x prime is negative 1 over x squared. Okay, so please remember that. Again, average profit, cost, revenue, and their derivatives. Distance, velocity, acceleration, and higher order derivatives. So, tell me what you would like to start with. So I'll keep this page handy so we can go back and forth. Yes, I'm ready. Any questions you may have from Pearson, from homework, from anything? All homework solutions should be reviewed, please. Please review all homework solutions. They are all posted, except the one from tonight. Say it again.
Can we start with 1?
Yes. So let's start
I
with
think
1.
2, 3, 4, 5, and 6 are pretty easy.
Okay, so let's start with 1 and then we'll come back to the page. Okay, so we can make one up. I'm looking in the book. I am on page, what page am I on? Or we can just make one up. Let's make one up. So here's a piecewise defined function. Okay, so here's an example of a piecewise defined function. And we're asked to graph it, we're asked to find the derivative, and so on and so forth. First things first. So number 1, graph it, or let me say A, graph it. In order to graph the piecewise defined function, remember we have to find its domain. So instead of this, you don't have to cross out anything. Can anyone give us the interval notation for this? Excellent. And for this one, I'm assuming the same. Clear. So when I'm asked to graph, first of all, I will have to identify the domain. Since there is nothing missing equals, it doesn't have to be like that. But in this case, nothing is missing. 1 and everything to the left. 1, not 1, and everything to the right. So then the domain is indeed all real numbers for this function. I will start my table, as we did so many times. Please review these from the previous classes. So I have negative infinity to infinity. 0 must be in the table no matter what, unless it's undefined, who knows, but 0 has to be there. 1 has to be here because I have a bracket to the left and a parenthesis to the right. To make sure that this is not twisted, from negative infinity to 1, I will write myself a note. Make sure you're using 2x squared. For the other one, of course, I'm making myself a note. Don't forget, use x minus 3. I plug in 0, I get 0. I plug in 1, I get 2, and I write it inside the bracket. What's the point of that? That tells me not to forget that this is full. On the other side, 1 minus 3 is negative 2. And for 3 equals 0, I always look for x and y intercepts if they exist. What's the point of this? Again, very clear. This will be open. In other words, this will be a hole. Or removable. If they are both the same, but they're not. So the hole can be removable, but not in this case. Not here. Because these two numbers are not the same. And the function exists like at that point. Okay. Perfect. So I have what I need. Am I still centered in both? I think so. So then in the next step, I try my graph. 0, 0. 1, 2. Parabola. Vertex at 0, 0. This is it. I'm done. Again, you don't have to do this. You don't have to take colors with you or any markers or pencils. No, I'm just making a point. So 1, negative 2 is this, and it's an open point. 2, 3. And here it is. Notice that by the vertical line test, this is a function. If you continue this graph this way, it will no longer be a function. If you continue this graph this way, it will no longer be a function. If I see something like this and for some reason, I don't know why, I will. I have no idea. I don't know how many times to say it. Please don't graph something like this because this is not a function by the vertical line test. And I will be honest with you and I'll tell you how many of these graphs I will find. Please, I don't mind begging you. Please do not graph something like this. Please. Okay, the next question for this function is this function continuous? So part B, continuous? What will you say? Is this function continuous?
No.
No, not continuous. What type of discontinuity and where?
Would be a jump at x equals 3?
At x equals 1.
1, sorry.
Perfect, perfect. Excellent, great. Now I'm going to ask definition of continuity at a point. So that's part C if you want. How do I write the definition of continuity at a point? It's a very important definition. I'm not asked to do anything with it. I'm asked to state the definition. State the definition of continuity at a point. What do I write? How do I write the definition of continuity at a point? The limit as x approaches a from the right must equal the limit of f of x as x approaches a from the right and must equal f of a. This has to be understood and learned and clear. So, of course, this doesn't make sense, but you know what I mean. This says that the limit from the left must equal the limit from the right, must equal the function value at this point. Then the function is continuous. If I have this, or I have this, the function is not continuous. The limit from the left must equal the limit from the right, and must equal the function value at that point. Okay, now the next question would be, find the derivative. So f prime of x equals, what is the derivative of 2x squared?
4x.
Excellent. We'll write this in a minute. What is the derivative of x minus 3?
1.
Very good. Perfect. So now, John told us already, this is not continuous. It's a jump at x equals 1. Here's my question now. If the function is not continuous at 1, will the derivative exist at 1? If the function is not continuous at 1.
Would we know?
No, not differentiable at x equals 1, since it is not continuous at x equals 1. So now be very careful. I can only write this. I cannot put the equal symbol here. If I put equal symbol here, I'm telling you that f prime exists at 1. But f prime does not exist at 1. The original function exists at 1. But because the function is not continuous at 1, the derivative cannot exist at 1. So the domain of the derivative is negative infinity 1 with a parenthesis union 1 to infinity. Any questions on this problem before we move on? Okay, perfect. We're coming back to the list. Yes, I think the compound interest and domain and the equilibrium point, but it's up to you. You choose the next topic, please.
We do number 9.
Yes. So let's continue with number 9. Number 9, differentiation rules. So the differentiation rules, product, quotient, power, and chain rule. Any functions that you want to pick. They can be from homework, they can be from Pearson, they can be from anywhere, any function you want to work on, anything. I think I'm on page 6. Yep. Please choose any function from anywhere.
I don't have one. Would you mind using one of yours?
Yeah, that's fine. So do you know what you would like to apply, or what rule you would like to apply or not, or you just want me to make one up?
Just make one up.
Okay. Good. So here's a function. We want to find its derivative. So we want to use differentiation rules. What if I want to find, oh, did I put that in? I'm pretty sure I did, but I have to check. Yes, number 8. Okay. So we are asked to use differentiation rules and determine the derivative. So how do I start? Which rule applies here? You can say more than one, and I would have to agree. But what is the main rule right now that we have to think about?
The quotient rule.
Excellent. Thank you. So when we say about the when we talk about the quotient rule, I have to immediately write this. Please do not expand. Do not write the 9x squared plus 24x plus 16. Do not expand denominators. It's a waste of time. Please. Okay, perfect. So knowing the quotient rule, what is the derivative of the top?
Just 2.
Good. Times the denominator minus the top. Can anyone give us the denominator prime? Very good. Perfect. So now I distribute. This was a very simple example. I could have made it more difficult by putting some powers here, but I wanted to just review the quotient rule. So this is 6x plus 8 minus 6x plus 3 over 3x plus 4 squared. These two go away, and the final answer is 11 over 3x plus 4. And this is a very simple situation.